Okay, this project is brought to you by Group 48. My name is Zeyad.
My name is Dishant.
My name is Simran.
And my name is Yousuf.
Okay, so the topic we chose is about how to make solar energy more affordable. For solar technology to become more affordable, companies need to be able to make use of economies of scale. This entails building utility-scale solar farms, which requires large tracts of land with ample solar radiation. The goal of this algorithm is to help utilities operators find suitable locations to place their facilities.
By providing average solar radiation levels, projected energy outputs, and minimum land area required to establish a 100 megawatt plant in a particular location, the program will also provide for the comparison of locations.
And the datasets is from National Renewable Energy Laboratory. We have 5 different datasets that are representing 5 different locations, which are Houston, Dallas, El Paso, Brownsville, and San Antonio. They provide hourly radiation that were taken over the course of a year. This data will be evaluated through a searchable array of locations and their average solar radiation levels. The user will choose via a menu to either compare location or individual search. If the user chooses a specific location, they will be able to allow to filter out the search by minimum radiation levels. Then the user will be able to select location from a menu of available locations. After the program runs and displays the chosen information, the user has the choice to rerun the program.
Now, before we go into the code, I'd like to point out that our project is split up into 2 sections here. The reason it is because we have a lot of data, and whenever we put it into one section, it takes a while to load. So as you can see here, we have all the different cities, and when you put them into the data, it separates like this.
So we have cell arrays, and by doing the cell arrays, we have combined it into an array. And now we're gonna show you how it runs. So here we have the data array. We have the cell array, and we have all our data in it. And then whenever you run the code, it's gonna ask the user if they want to compare or do the individual search. So I'm gonna do compare. Okay, whenever you do compare, it also tells us the available location for the comparison. And we have Dallas, El Paso, Houston, San Antonio, and Brownsville. And we could choose up to 3 locations. But for comparison, well, we could only do 2. So I'm gonna do Houston, and then I'll do Dallas. And for the third one, I'm just gonna enter. Okay. So we have our information for Houston and Dallas. For Houston, we have the average radiation levels, which is 532.04, and then we have the average maximum radiation levels, which is 175.22, and how much land area is going to require, which is 290 acres. And then we have our average daily energy output for that plant, which is 49.40, and then for location 2, which was Dallas, we have our average radiation level, which is 570.39. Then we have our average maximum radiation level, which is 180.87. Then land required for that rated plant, which is 271. Then average daily energy output for that plant is 47.57. And then now this is a comparison between numbers, but now on top of that we did the plotting, and we could actually see it, like how it actually looks like on the graph. So here we have our average daily energy output. On the left hand side we have Houston, on the right hand side we have Dallas, and the maximum it could go up to is 50. And on figure 2 we have the average maximum radiation levels. On the left hand side we have Houston, and on the right hand side we have Dallas. And the highest it could go up to is 200. And as you can see, Dallas number is higher, so it's the maximum radiation on the right hand side is much higher than than Houston. And on the third average radiation level, we have the maximum is 600, and on the left hand side we have Houston. On the right hand side we have Dallas. As you see, on in Houston we have the number is really low. It's close to 532.04, and the average radiation level for Dallas is 570.39, and you can see how much different it has. And not only that, we have our we made a function which has the calculations, and then we made a for loops, and then it asks for the user to for if they want to rerun the if they want to reperform the thing. Another search. Well, for right now, I'm just gonna click no, so it's gonna end the code, and then it's gonna give me all my values. And as you see here, we have all our values, and then we have our for loops. We have different data sets.
So this next part of our code is the individual location part. So when you run the code, it asks you to compare an individual search. You will click individual search. With this, you can choose a city and it will give you all the relevant information rather than comparing cities. Before we get to that, you have the option to filter location by minimum average radiation levels. For right now, we're going to skip that and just do the basic city selection. So I hit no, and down here you will see the available locations are all 5 cities in the dataset. We will go ahead and select Houston and hit enter, and what it shows is the city that you selected, average radiation levels, the average maximum radiation levels, the land required for 100 megawatt rated plant, and the average daily energy output. It hits the end of our code, and you select yes for performing another search. Go back to the individual, and this time we will filter. So what this does is for whatever minimum average minimum radiation level that we choose, the cities that don't meet that requirement won't be shown up for the locations that we can choose. So I'll select yes, and I will enter in 1050, hit return. So the cities that did not pass the minimum average are Houston, San Antonio, and Brownsville. So from here we will select, let's go with Dallas, hit enter, and it will show you the same as before with Houston, the averages, the land, and the energy output. We can perform one more search to make sure everything works correctly. Do an individual, and we'll select one more city, San Antonio. Hit enter, and there are the levels for San Antonio. If we select no, then it will exit out of the code. And if I take you through the steps here, if we scroll through, we start over here. This brings in our search choice. We go through the filter if you select it or not. And this is all filter information. We get down here to where it will pull out the locations. And here is where the data is calculated and is displayed. You can see here the average high, average plant size, and all the calculations and all the displays. And the control center is down here. If you select yes, it'll take you all the way back up. If not, then it'll end right at the bottom. So the result of this project is to organize radiation data per city, and the outputs show average radiation levels, land required to produce a efficient plant, and it shows graphs to compare cities. This code
is meant to help companies choose locations so that they can judge them by various factors and further make a decision if a place can be used to set up a solar plant efficiently and cost effectively.